Alright, so this is what if you're following along, this is what your dashboard, your project should look like. If you want to, I'll actually just go back and show you how to get here. On this left here, once you've made your account, you go to circuits and you hit create new circuit, but I already have this one up. So I'm just going to go ahead and open it back. What we are going to be using for this class, in here there are all sorts of different options. There are microbit, there are various Arduino boards, but we are just going to be using the regular Arduino Uno with a breadboard. Most of the stuff will be using a breadboard. Breadboard just allows you to have more spots to place things, and things are nice to have. So we're going to go ahead, and the first thing about this that we'll talk about for this particular assignment here is that it is we're just going to use a button and turn on a light. If you remember, I did on the stream a very quick hello world, and this will be something very similar. So what I'm going to go ahead and do here is, first thing that I'm going to go back to my basic components, and you can see this breadboard, when I already picked it, it automatically connected it with the power. Ground is negative, your black cable, and you want this to be hooked up to 5 volt on your power supply up here. We will just be using for this these digital pins. We will only be needing 2 of them, but that is all that we're going to go through here. So first thing I'm going to do is just place an LED. I'll just put that right here. And what I want this to do right now is, well, at the moment, nothing. I haven't connected it, haven't set it up, but what I want it to do is turn on whenever I press this button. I can just go ahead and I can leave this as the name 1. I can leave this as the name 1. It doesn't really matter. You won't be referencing these names necessarily. So nice thing about the Tinkercad is that if you click or if you hover over the legs of the pins, is what these are called, that plug in, it labels them. So this tells you this is the cathode and this is the anode. Just so you know, the long leg is positive and the short leg is negative. If you were using hardware, that will just give you a short circuit, and that's not good. But if you were using Tinkercad, it's completely fine. It will just not quite work there. So the first thing that I'm going to do is set up the wires, set up this breadboard, get this all connected. And I'm just going to say I'll use this 8 pin here. I'm just going to put that right there with that red or that LED, excuse me. And I'll make this LED blue and color code the wire blue as well. You don't have to do color coding in your stuff, but I like to because it can get pretty cluttered pretty quickly. Next thing I'm just going to pop in here is a resistor. This is for the attached to the cathode. The resistor, it takes a certain amount of kiloohms. For most things, it's 220. Or at least most of the things that we will be using, but it's different for everything. The way you can tell how many kiloohms resistance it has is by these bands. I can link a chart later after this that shows you how much each band, what color it represents, and all that. But for right now, just kind of slap a 220 on there and it'll be fine for this LED. And this is connected to the negative side. For the button, we're going to have another resistor, and it's going to come onto this left side, but it's actually going to come from the positive. It will again, I'm just going to replace it, going to be on 220 kiloohms. And what we're going to do here is connect. We'll just put it right here, and this is going to be connected, we'll say to 9. And we will color it. We'll just leave it as green for the button. And that's going over to 9. Then we need to connect this, we need to ground it. So we just take this, connect it there, black. The way Arduino works is that this on these outside, these red and black lines show the orientation. So the connection goes this way on these outside lines, and then on these individual rows that are numbered 1 through 30, it goes this way. So everything that's going through this row will be applied to the one next to it. Also, if you, just a little Tinkercad bit of info, if you want to rotate any object that you have, I don't want to rotate that board, but if you want to rotate it, you can just press R once you have it highlighted, and then you can move it to your liking. That'll be a little easier for some other stuff, but right now that's fine. We can just plug it in as is. The next thing we want to do is, well, we have everything connected from the breadboard onto the Arduino board. And now we are going to start looking at the code. So the code is like C++ or C, and it's a little bit, it's different from Python, and it does not matter if you have no experience with this. Like I said, I will also be linking the Massimo Bonzi video, which I would hope the creator of Arduino would do a better job than me, but he also walks through what these functions do. So I'm going to go ahead and pop open the code here. Right here, it's up at the top, and you can also, if you like that, you can use blocks or you can use text. It is completely up to you. I personally use text, and that is also what Massimo Bonzi and all of your most of your resources will say in terms of like if you're looking up Google for help. So now we're going to look at this and see what is happening. We have something that says void setup, void loop. What happens is our setup is what happens when you first turn on the board. In this case, it's whenever you plug it in through this cable. If you click start simulation, you can see it plugs in. You have power. Your board is on. You can tell by this little light right here. Now it's off, disconnected. That's what would have gone through the setup right there. And then after the setup has gone through, it has this loop, which will, while the board is plugged in, it will try and do whatever's inside of this. Before we get into the setup, though, we want to set up some variables. I'm going to say const, which is constant, int, which is integer, and we're going to say our button is our variable name. That equals 9. You can see I just found the 9 over here where it's connected and just set it up like that. How the C++ syntax is, after you finish a line and it is done, you add a semicolon to the end, just like over here and here. Additionally, if you want to have syntax, or comments rather, you do 2 slashes, and then you are free to type however much you want. So we're just going to say that's our button variable. We need another variable for the light, which is const int, we'll just say LED, and this is on our 8-pin. We're going to use the semicolon to block that off, and our LED variable, just like that. We're going to get another command here for another variable for our button state, not a constant integer, but a fluid one, but it is an integer. It starts off on 1. Basically, this is saying the state of the button. Is the button on? Is the button off? And that will be reading that. So if you look over here, next thing we're going to do is actually go into this setup. We're going to use this pin mode function here that's already in there, and that's basically determining whether a pin is an input or an output. In this case, an input would be something that you do to the board, an output would be something that the board tells you. So we're going to change our first item in this element of parentheses will be our button, and our button is our input. We're going to do this again, same pin mode We're going to call it our LED this time. This is our output. Very simple stuff. The hardest part about doing this is learning the new syntax, which you won't have to go through and find all this syntax in its entirety, but that's just sort of how this program works. And again, like I said, I will be posting a video that you can follow along to and all that sort of stuff. But first thing that we're going to do is we put our, just a reminder here, our variable setup. These are our constants. These are the pins. These are not changing. And then we have our LED. Again, that's not changing. We have our integer button state. That is not changing as well. Sorry, that is changing. Next thing we want to do is we want to go into our, we're done with this setup. Actually, excuse me, no we're not. Serial.begin. This is, if for right now, if you're just following along and you don't really understand, that's fine. This is just another Arduino stuff that we're going to have here. So now we're going to actually go into our loop. This is what's going to be happening during the meat of while this is plugged in. What do we want our Arduino to do? What is it looking for? What is it telling us? That sort of stuff. First thing we want to do is we want to determine what our button state is. We want it to tell if I'm pressing the button, turn on the light. And then if I am not pressing the button, turn off the light. So we're going to use that by setting this variable equal to the digital read. That is a function of button, our variable up here. Close it with a semicolon. Basically what digital read does is it determines if it is high, which is on, or low, which is off. Basically, that's sort of other programming languages will say true is 1, false is 0. This is essentially saying on is high, low is off. Now we're going to be using a if conditional because we have two things that will happen depending on the two situations that are occurring. So if our button state, which is determined by that digital read, 2 equals sign low, remember we're not, this is another syntax thing. If you're doing a Boolean, if it is low, then we want it to do this. You see, I didn't use a semicolon there. I used this open bracket because there's a function that's going on in here. What we want it to do now is digital write, which is the opposite of digital read. Digital write will take a pin and switch it from high to low in the case of these digital pins. There are also analog pins for other things that are not just on or off. Like if you have an LED and you want it to be on half power or quarter power or whatever, that's when you would use the analog pins. But we're just going to use the digital. We just want it to be on or off. So LED high. Because remember, this is saying if excuse me, if this button state is low, we're going to switch the LED to high. Go on the next one. This is using that serial print ln. Remember, we just started this with up there. This is not necessary, but I think it's just kind of nice to show that the light is now on. That'd be nice if we had, especially if we had an LCD screen, liquid crystal display, and that would just be another thing you can hook up and kind of tell you, but it does not really serve a whole lot of purpose, but I just think it's a nice little thing to add there. And then what I'm going to do is then I'm just going to put a delay. This is in milliseconds. I'm going to say 500 milliseconds. So if I press the button, it'll wait half of a second after it turns on the light, and then it will check the if loop again. So basically, if I just click the button really fast, it'll be on for 500 milliseconds, and then it will go through the loop again and see that the button is no longer being pressed. So if I held the button though for more than 500 milliseconds, then it would go through and continue with this loop. But that is all we have for the if right there. We're going to go ahead and close it off with that curly bracket, which we start up here. And we're going to move on to the else. Because if this is true, we want to do this, and else, meaning if that is not true, we want it to do something else. Very intuitive language C++ is. We're going to be doing, we don't need to check this digital read because there are only two modes, on or off. So right now we're assuming if it was off, we're going to say digital write our LED to low. And that will be turning it off. Then we're going to go back to the serial print and update that. Serial print ln light is off. And then we will use our parenthesis, close that with a semicolon. And we're also going to put a delay there. And we will make it a little shorter, maybe 250 milliseconds, quarter of a second. And then we're going to go ahead and close this with our curly bracket. And that's all we have for this fairly simple button testing. Mainly, the main thing you want to get out of this is setting up the board, which is putting things on the right side, and then getting the if conditional. Most of this stuff is fairly similar to just like the basic hello world. But now you can see I started the simulation. It's plugged in. We have power. Nothing is happening. If I press it, it turns on. Right now I'm holding the click button, so it's staying on. But if I let go, it turns off. Again, I can click it, turns on, let go, turns off. And that's sort of a very basic idea that I'm going to start us off with, and then it'll hopefully grow. Like I said, there are a whole lot of different available options for what you can do with Arduino. I highly recommend, if you want to see some application, big YouTube channel Mark Rober. He does a lot of stuff with Arduino, making sensing and working items. And just a real quick heads up before I continue, those of you who are coming in a little late, this is just a very basic thing right here. I will be posting a video on this up later today. Anyway, so we have our simulation that turns on the light when you press it, turns it off when you're not pressing it. Something you can do if you wanted to edit the code is you could just remove these delays. Remember, quick little sidebar. If your simulation is running, you cannot alter your code. And whenever you run your code for the first time, before it starts the simulation, it will debug, or not debug it, but it will check to see if all of the syntax and stuff is valid. So now I turned off that delay. So whenever I click it, it's on, click it, it's off, and that's a little more responsive. So, yes, question. So the serial monitor is actually, it's honestly not even being used right now. This is sort of just like in the part of like the board. Like if we could like reference this, or we could output this, but honestly right now we don't even need this in here. It would be fine without it. But there'll be just some stuff that we do where you will have an output for it. Like you could do, if we look back here, just close all that, but you can look in here, see what you could use it with. Like you could put it on, it's not going to be in the basic, but if you did an liquid crystal display, you could do that. And we will get to our fair share of using these tools. I'm going to try and cover as many of these with like a real application, and that's something that is very nice about this book, that the project book that we'll be following, is that it has simple tutorials on all these things that shows us the code that we'll be using, the item that we are making, what it does, how to build it, and that is going to be, hopefully as we get through this, something that we can apply to the real world. This is one of those units that has some real application. Microboards and stuff, and getting technology, computers to do what you want is very important. The last unit we covered was cryptography, which is the introduction, the basis for cybersecurity and that sort of stuff. We're going to be trying to relate this all to actually applicable real life experience. So I'm going to go ahead and end this video now. But if you have any questions, feel free to DM me.